Hello, today we'll be talking about prime factorization. Prime factorization is a very helpful tool when it comes to finding patterns and relationships between factors and multiples for a given set of numbers, okay? So let's try start with an easy example. Let's prime factorize the number 24. So there's multiple ways you can like write the process of how to do it, but okay, this is what I do. So we write the number, right? And then we write this, okay, this these lines, and then okay, what is the smallest prime number that divides into 24? Okay, let's start with the first prime numbers. We have 2, 3, 5, 7, 11, right? The first few prime numbers. Okay, which is the smallest prime number that divides into this number 24? It's 2, right? Okay, so let's write 2 over here. And then what's 24 divided by 2? We get 12, right? Okay, now what's the smallest prime number that divides into 12? It's 2 again. So we have 2 again here. And now 12 divided by 2 gives us 6. And again, we can use 2. And 6 divided by 2 gives us 3. But now we can't use 2 because 3 isn't divisible by 2. But 3 is divisible by 3. So now we have a 3 here. And that gives us a 1. And we know we are finished when we reach the number 1. So now we multiply all of these numbers on the sides. So we have 2 times 2 times 2 times 3, which is the same as 2 to the power 3 times 3. This is the prime factorization of the number 24. Okay, let's try another example. Prime factorize the number 81. Okay, is 81 divisible by 2? No, it's not. Is 81 divisible by 3? It is. Okay, so let's write a 3 here. And what is 81 divided by 3? It's going to be 27, sorry. Okay, so 27 is not divisible by 2. Is it divisible by 3? Yes, it is. So what's 27 divided by 3? It's going to be 9, right? Okay, for 9, again, we use 3. So 9 divided by 3 is going to give us a 3. And then we divide it by one more 3, and we're going to reach 1, so we're done. And then we multiply all these numbers on the side, and we get 3 times 3 times 3 times 3, which is the same as 3 to the power 4. Okay, now let's try to use this prime factorization method to try to find the LCM of two numbers. Okay, here's our first problem. Find the LCM of 26 and 12. Okay, so let's write both of these numbers in our diagram. Okay, this time instead of looking at only one number, we look at two numbers at the same time. So what's the smallest? Okay, what's the smallest prime number that I can divide into any one of them? It doesn't have to be both of them, it can just be any one of them. So our prime numbers were 2, 3, 5, 7, and 11, right? Well, 2 divides into both of them, right? So we have 2 here. 26 divided by 2 is 13. 12 divided by 2 is 6. Okay, now we can, what's the smallest prime number that divides into any one of them? We have 2 again, because 6 is divisible by 2. 13 stays there because 13 isn't divisible by 2, but 6 divided by 2 gives us 3. Okay, now 2, it doesn't work. 3 works, right? Because we can divide 3 by 3. 13 is divisible by 3, so we keep 13 again, and 3 divided by 3 gives us 1. Now we have one last number to work with. And 13 is actually a prime number. So then we just divide it by 13. So we're left with 1, 1, so we're done. So the LCM of 26 and 12 is going to be 2. And multiplying these numbers on the side, 2 times 2 times 3 times 13, which gives us 12 times 13, which gives us 156. So that's the LCM of 26 and 12. Okay, let's try a more complex example, okay? 2. Find the LCM of 24 and 15. Okay, let's list out all our prime numbers again. Okay, what's the smallest prime number that divides into any one of them? We have 2, right? Because 24 is divisible by 2. 24 divided by 2 gives us 12. 15 is not divisible by 2, so we keep the 15. Okay, now we can divide 12 by 2 again, and we get 6 and 15. Divide 6 by 2, and we get 3 and 15. Now 2 does not work anymore, since they're both odd numbers, so they're obviously not divisible by 2. Is any one of them divisible by 3? Yes, both of them are divisible by 3. So 3 divided by 3 gives us 1. 15 divided by 3 gives us 5. Now we just have 5 left, and we know 5 is a prime number. So we divide it by 5. And now we get 1, 1. So LCM is going to be the product of these numbers, which is 2 times 2 times 2 times 3 times 5, which is 8 times 15 equals to 120. So the LCM of 24 and 15 is 120. Okay, number 3. Find the LCM of 10, 18, and 20. Okay, this time we're going to find the LCM of 3 different numbers. So we have 10, 18, 20, okay? And our prime numbers were 2, 3, 5, 7, 11, and 13. Okay, what's the smallest prime number that we can use here? It's 2, right? All of them are divisible by 2. 10 divided by 2 gives us 5. 18 divided by 2 gives us 9. And 20 divided by 2 gives us 10. Okay, now we can use 2 again because 10 is divisible by 2. 5 and 9 stays the same because they're not divisible by 2. 10 divided by 2 gives us 5. What's the next smallest prime number we can use? We can use 3 because 9 is divisible by 3. 5 and 5 stays the same because they're not divisible by 3. 9 divided by 3 gives us 3, and we have a 5. We can use 3 again to reduce the last 3 to a 1. 5 stays the same, and we get 5, 1, 5, okay? Now 5 is a prime number, so we just divide it by 5, and we should get all of them reduced to 1, 1, 1. So now we just find the product of these numbers on the side, and it's 2 times 2 times 3 times 3 times 5, which is equals to 4 times 9 times 5 equals to 4 times 45 equals to 180. Okay, now let's look at HCF, or you can also call it GCD. Highest common factor or greatest common factor. Okay, problem 1. Okay, problem 1. Find the HCF of 12 and 18. Okay, so again we write the 2 numbers in the diagram, but this time we actually do something different. You'll see what we do different. Okay, so let's write our prime numbers again. 2, 3, 5, 7, 11, 13. Okay, what's the smallest one divides into both of these numbers? So notice that before with the LCM, like we only look, if one numbers, for example, if we have like 5, 3, 5, as long as one of them is divisible by 3, we can divide the whole thing by 3, right? And the 5 stays the same. But in a HCF, this is the simplest form because you have to find a prime number that divides into all 3 of them at once. Okay, so 2 divides into both of them, right? And now we have 6 and 9. Well, when we're finding the LCM, we will normally divide this now by 2 and divide the 6 by 2, right? But now we're finding the HCF, and like I said before, HCF, we have to find a number that can divide into both of them at the same time. So 2 would not work because 9 is not divisible by 2. So 3 works though, right? because 6 divided by 3 gives us 2, 9 divided by 3 gives us 3. Okay, we can't use 2 because 3 is not divisible by 2. We can't use 3 because 2 is not divisible by 2. And the prime number is so on the way too large. So then we know this is going to be our simplest form. So the HCF is again going to be the product of the numbers on the sides, which is 2 times 3, which is equals to 6. So that's how HCF. Okay, problem 2. Find the HCF of 24 and 36. Okay, so the smallest one that can divide into both of them, the smallest prime number that can divide into both of them is 2, right? 24 divided by 2 is 12. 36 divided by 2 is 18. We can use 2 again, right? Because both of them are divisible by 2. So 12 divided by 2 gives us 6. 18 divided by 2 gives us 9. Now we can't use 2 because 9 is not divisible by 2. So then we have to use 3 because both of them are divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Okay, now we're in the simplest form again because we don't have a prime number that can divide into both of them at the same time. So our answer is the product of the numbers on the left. That is 2 times 2 times 3, which is equals to 12. So HCF of 24 and 36 is 12. Okay, problem 3. Find the HCF of find the GCF of 15. No, not 15, sorry. 26, 16, and 18. Okay, so now let's write these numbers in our diagram. Okay, what's the smallest number divided into all of them? 2, right? So now we're left with 13, 8, and 9. Okay, 8 is divisible by 2, but 13 and 9 are not, so we can't use 2. 9 is divisible by 3, but 13 and 8 are not, so we can't use 3. Okay, well, let's write our prime numbers again. So we know 2 and 3 does not work. What about 5? None of them divisible by 5, so that doesn't work either. What about 7? Again, 7 doesn't work. Next prime number is 11. 11 doesn't work. Next one's 13. 13 is divisible by 13, but 8 and 9 are not. And then any prime number is so on too big to be divisible by these numbers. So that means this is our simplest form. So the HCF of 26, 16, and 8 is just going to be 2.